complicated way because there are so many things I can ask about sine and cosine. But for tangent and cotangent and secant and cosecant, you need to know only this part. And a little bit, I'm going to ask you guys how the graph of tangent of 2x looks like. So you have a good feeling that the question about tangent, cotangent, secant, cosecant will be super easy. It will be related to your homework. So something about tangent of x, we learn tangent of x, the period is pi from here to there. And we start, so that this is a graph of tangent. How do we graph it? Through the table, correct? Or this is a calculator, graph tangent. So the range of tangent of x is between negative infinity to positive infinity. Oh, screen is small. So do you see the screen big or small?
I see it big. We can see it.
We can see it. So you see all the images here, and then canvas is here. I'm trying to redo it somehow better that you guys see my hands where I'm pointing. So far, I wasn't able to find any program. But anyway, so the range of the graph, we talked about domain and range, right? So what is the range of tangent of x? So range, we deal with the y, correct? If you guys remember, we start this course with domain and range, input and output. So we said input are the domain, output are the range. And the output, the value output, which is same as y, are the range. So if you see the graph, this goes to positive infinity, and this way goes to negative infinity. So the value of y changes from negative infinity to positive infinity, correct? So that's the range of tangents. What is the domain of tangents? In the graph of tangent, we see that we have pi half vertical asymptote, negative pi half, and this keep repeating. For example, at this point is pi half, then we have 3 pi half, correct? So how do we list them as a domain? That means if this was a factory, we cannot plug pi half inside of this. If pi half goes inside of the factory, tangent of pi half will be infinity. It doesn't exist, so there will be no output. So we need to prevent that. So somehow we have to put a gate here that says we don't accept pi half. But there are so many of those, correct? All the blue one. That means we should then this continue. How do we list them? Just let me have one slide here. I'm going to make an example. Make it better. Y equal to 2 over x plus 5. What's the domain of this function? What's the domain of this function? We went through this, right? You knew domain and range when you take this course, but at the end of the course, domain and range should be something that makes sense to them. That means, should I plug all real number to this function, or there are some restriction? Can I plug any number to this function? If it's
No, because the denominator can't be 0.
very good. So that's what I'm asking. So we cannot plug -5. So domain will be all real number minus set of -5. That means on the number line, this is 0, that's -5. This is negative infinity, that's positive infinity. We can plug any number here all the way, but not -5. This is one way to show it that I believe you guys like this way. Anytime we have a rational function, that's the way we need to present the domain. Or we can say parenthesis -infinity, comma -5, close the parenthesis, union by parenthesis -5 goes to positive infinity. This is exactly same way to write the domain. This is same as this one. So the point is, when they ask you the domain, you need to tell your audience or your customers what X's they're allowed to plug in. If you come up with a formula that you want to sell it in Amazon, somewhere on the note sheet, you need to say who should use this formula. You're going to say everybody not age -5, everybody but not -5, right? That means domain. So back to tangent of X. Tangent of X is sine of X over cosine of X. So we have a rational function. We can say all real number minus, if you say cosine of X equal to 0, this is not okay. I mean, we cannot have cosine inside. We should have all the values. So what on the cosine of X, what X makes the cosine of that is 0. We have, because it's periodic, we have so many. If you say graph of cosine, all those things should be out. We need to list it. To make this story short, we just follow this guy. This is cotangent, we are here, tangent. So the range is -infinity to positive infinity. Make layer visible. This is visible. Oh my God, what's happening here? Okay, doesn't like the image layer. So those are the line, those are the point that we need to list them, that domain are not those. How do we write it is this one. Domain is X such that X cannot be 2n plus 1 multiplied by pi half. And n is an integer. What does it mean? So the first thing we should do, so this point is pi half. We cannot say domain is, we cannot just say R minus pi half, 3 pi half, 5 pi half. Somehow we need to make a formula, and the formula that is this guy. If n equal to 0, it will be pi half, which is, are you guys following me? So n equal to 0, we're going to have 2 times 0 plus 1 multiplied by pi half, it will be pi half. N equal to 1, we have 2 times 1 plus 1 multiplied by pi half equal to 3 pi half. What are those? Those are, and so then n equal to 2, n equal to 3. This, so when you write it like this, so we get it that we cannot plug those numbers. So for the domain of tangents, this is the domain. It should make sense to you now. You will have it in your note sheet, and there's no challenging question about this. Any question? Question? No question? So they said the graph is discontinuous at value of x 2n plus 1 multiplied by pi half. Discontinuous means the graph goes like this. Everything is continuous. The next one going to be here. That means here we have discontinuous. They're not is not connected. Has a vertical asymptote of those points. X-intercept has an x value of from n pi. Again, we have n here. I know you guys don't like the way n got involved here, but n is an integer. For example, let's say n equal to 0. We have 0 times pi is 0, which is here. That means this is an x-intercept. When n equal to 1, we have 1 times pi equal to pi, which is here. That means another x-intercept. Then n equal to 2, we have 2 pi here. If it's negative, we have negative. So those are the x-intercepts. There are no minimum and maximum value. Because this error, we're never going to say the maximum of tangent is like a 10 million. No, we might have 10 million one. So there is no limit for the minimum and maximum. Because of that, there is no amplitude. Amplitude happens from between the maximum and minimum for sine and cosine, but for tangent, cotangent, secant, and cosecant, we can see it, we cannot find the height. The graph is symmetric with respect to the origin, so the function is an odd function. Definition of odd was f of negative x to be negative f of x. This is odd. Also, algebraically, we can see that tangent of negative x equal to negative tangent of x. One of the property of odd function was if you reflect it to the origin, you will get the other parts. That was odd. The even function was y-axis will cut the graph. This is even. When this y, cut the graph exactly half. Any question for this review? Are you guys there? Maybe. Okay, Karen, that's good. At least something like this makes me move on. Angel, Marcia, Nicole, Jake, Elizabeth. We are losing people. Anyway, okay. There is no question. Let's move to cotangent. Similar to tangent, cotangent, the graph is, no, I can do it. The graph of tangent was like this. Graph of cotangent is like that. So again, we graph it through the, I mean, we did go over this in one of the sessions, but again, we through the table, we graph it. Same as tangent, the range is between negative infinity and infinity, because of this goes to positive infinity, and this is going to go to negative infinity. We need somehow tell we need to find the x-intercept. Those points are the x-intercept. So this is pi half. This is 3 pi half. Those are value of x-intercept. So it would be 2n plus 1 multiplied by pi half. 2n plus 1. Just something for your note sheet. 2n plus 1, always output is odd. For example, for any n, you plug it there, the output will be odd. If you say 2n, we'll get even number. All right. So because all the x-intercept are odd, so we put 2n plus 1 multiplied by half. And the domain will be, those are the domain that we need somehow, we need to tell, we shouldn't plug those number. What are those? Is all like a 0, pi, 2 pi, 3 pi, 4 pi. So how do we say it? We're gonna write x cannot be n pi. Any multiple of pi, and n is integer, is not fraction. So n 0, 1, 2, 3, 4. And cotangent is odd function as well, because it is an odd function. The period is pi. The graph discontinue at x n pi n pi. Again, it discontinue at any of multiplied by pi. All right, let's have one question for you guys. No, I can be quiet. You guys pick it. So which one is which? We are shifting at pi over 4. Are we shifting pi over 4 to the right, or we go to the left? Karen?
I think it's going to the left.
We go to
Or-
the right. If it's negative, we go to the right. I know, because it's negative, you like to go to the left, but we do opposite. Maybe we went through this one. So this, we go pi over 4 to the right. So this was F. F is not correct. You said B.
I said F, but I said that I wasn't sure.
Uh, so you have a statement after this. So I think it's B, because the graph of tangent is like this. And here is negative pi half. And this is pi half. Now, if you have pi 4 to it, that means you're going to go pi, and they are showing pi over 4. So you move pi over 4 to this side. So it will be B. Somehow I would like you guys like this type of question better than some algebra question. In algebra, like a quadratic or solving for x, you have to do so many steps to find x. But for a question like this, a little higher scale, you just need to look at it and analyze it, so which one is which. So have a good feeling. And number 10, cotangent. You have the graph of cotangent. Graph of cotangent is like this. Okay, this is pi, and this is pi half. What type of transformation happening here?
To the right, pi over 4.
Yeah, and which one you think would be good solution? So the graph should be like this. This is a good candidate. Also, this is a good candidate. But pi over 4 to the right, correct? Because it's negative, we go to the right. should be D, correct? The graph was like this. We shifted pi over 4 this way. Jake, does that make sense? I mean, Elizabeth? No, you guys are there, not there.
Yeah.
Okay. Angel Hernandez. You guys make me to have a create a difficult exam for you guys. All right, so D is correct. What about 11? We are dealing with cotangent. The graph of cotangent is like this. Plus pi over 4, we shifted to the left, which will be this guy, F. And last one is tangent of x plus pi over 4. Tangent, we love it. Now it looks like this. Pi over 4 plus we go to the left. It will be something like this, which is E. Please like this type of question. Let's have one. Okay, let's do this one. I think we're having less students because I keep asking, you guys not showing up, correct? Because it's scared that I pick you. Doesn't matter if you don't. So now this is a homework question. I'm gonna ask Karen. 2 tangent of x.
I think D.
We think is this is a graph of tangent. We have asymptote here, which is negative pi half and pi half, correct? What is the period of this graph? Period is pi. We learned tangent of x has a period of pi. If there is a number here, if there is a like b here, we divide it by that, same as sine and cosine, but there is nothing, it's like a 1. So all of them, so this is pi, this is pi, this is pi, and that's why, great. All of them has a period of pi. So now, this 2 is positive. If it was negative, we will switch it. It goes up and down. So this is off because it goes this way, goes like this. So this is out. Also, this is out because it comes from this side. So we have 2 candidates, D and A. On your note sheet, you have a tangent of like a pi over 4. Here is 1. Good. This is tangent of x. Tangent of x at pi over 4 is 1. So now what about at y equal to 2 tangent of x? Now 2 tangent of pi over 4. This is pi over 4 is 1. 2 times 1 is 2. So the graph should go a little higher. Little skinnier. So which one? So it comes a little skinnier than tangents. Is that A or D?
D.
D. Also, they show it to you guys. So if this is pi half, this will be pi over 4, half of that. This is 10. So we have 8, then we have 6, we have 4, we have 2. So this shows you this is 2. At pi over 4 is 2. So D will be correct answer. So just we are analyzing, we are not doing algebra. Let's have another homework question. I think this is, oh, this is cool. I'm not gonna pick anybody, but can you guys work on this? I don't want to lose more people. So this is a good candidate because the distance is pi, negative pi. We have vertical asymptote here, and that this is 1 period. And this is out because it's going the other direction. So the good choice is C. This is going to be the most complicated tangent question for you, or cotangent question for you. So the way I step by step went through, that's what you need to do to pick it. Any question? No question. Very good students here. They don't ask me anything. Oh, this is a good question. Whoever answered this, don't Google it, guys. I know it should be in the Google. I give you guys nothing. But try to, so this is a homework question. Should I make a multiple choice? Is that A, B, C, D? Is that 1, 2, 3, 4?
4.
Yvette, 4. Who said 4?
It's me, Karen.
Karen. Not thinking, not guessing, just pick 4 for sure.
No, I was thinking about it because I was remembering from the homework.
Oh, very good. Okay. So how do we solve this type of question? No, the looks is totally different, but we have from negative 2 pi to 2 pi. We don't want to go to the unit circle to find negative 2 pi from here and then go to positive 2 pi. It would be, we cannot visualize it. But if you make a number line, if you make a number line, good, and I make a number line here and this one. So this is x, that's y. I'm going to graph tangent. So from negative 2 pi, this is negative pi half to pi half. So you have to make it smaller. So many meetings today. So this is the graph of tangent. We have pi half to negative pi half. All right. Then we have another one here, vertical asymptote. Pi half, this is pi. This is 3 pi half. This is 2 pi. Good. So they said 2 pi. So I'm going to include this guy. And we do the same thing the other side. There's going to be negative pi. This is negative 3 pi half. How do I know this? I know it from that slide I showed it to you guys. You should have this in your notes sheet. Then we have this going to be negative 2 pi. Good. So we have from negative 2 pi open circle to 2 pi close. I said if C equal to tangent of x, for example, tangent of x equal to 4. If x equal to, if C equal to 4, this is 1, 2, 3, 4, you make a line. How many times this line cross the graph of tangents? I know there are more here, correct? But they said between this interval, negative 2 pi to 2 pi. So one of them is here, correct? Which is, another one is here. There are less than negative 2 pi. We have here, we have here. And I cannot include this one because this is close to pi. I mean, this is a closed brackets. And that's open. So any line that you pick, any line, it will cross at 4 of them only. So the answer is 4. Any question? Now you know, does that make sense, Karen? That's how we solve it.
Yeah.
If instead of the domain negative 2 pi to 2 pi, if I make it from negative pi to pi, then it will be only from here to there. So we're going to have only 2 solutions. So don't memorize the question. Don't think I'm going to have same interval in exam. All right, let's, that's a graph of secant. Secant is 1 over, so secant of x is 1 over cosine of x. So if you graph the cosine of x, oops, what I'm doing, so this is a graph, this is gonna go here, here. So if you reflect that and you apply, I mean, this is a graph of secant. We went through this last week for secant and cosecant. But you need to know the domain and range, the period is 2 pi. There is no x-intercept. This graph, it doesn't touch the x-axis here. And secant is an even function because cosine is even. This is discontinue at 2n plus 1 multiplied by pi. Graph of cosecant is reciprocal of sine. Sine, the graph was like this. at this point is 0, but if you put 0 on the 1 over 0 goes to infinity. So that's the graph of secant. You should have it in your note sheet. The period is 2 pi. This is a period. And then it keep repeats like this, like this, like this, like that. I don't need to go over this. Do we have time? Wow. All right, there's last one about simple harmonic motion. That means if we have, this is a one of the layers is on, it makes a noise now. So the idea is if, for example, I get this mask, if this is a spring, if I put the weight here and pull the weight down and let it go, not this one. So this will, oh my God, what's wrong with this? So what's happening? So this is a rest, correct? I pull it down and let it go. So it will go something like this. This is they call it simple harmonic. Why they call it simple? It doesn't go like this. It doesn't go crazy that you cannot graph it. It looks like in some simple harmonic, it will be y equal to, I'm going to call it a sine of bx, or y equal to a cosine of bx. So the good thing is they look like graph of sine and graph of cosine. That's it. So we deal with only simple in this course. We don't deal with the crazy one that I graphed here. All right. So there are a couple homework questions on regarding the simple harmonic. One of the, for example, I give you y equal to 6 sine of tx. Why I put t or sine of t, not x. So t represents the time because it goes by in 5 seconds, for example, then it will stop. Correct? At one point, gonna stop. So if this is a equation for that simple harmonic, then I ask you, what is the amplitude? Karen, what is the amplitude here? It will be 6, correct? Same as before. 6 will be the amplitudes. If it's asked, what is a period? Period will be 2 pi because it's 1 here. So the same story as what we learned about sine and cosine. Amplitude will be absolute value of A. Period will be 2 pi over B.